Welcome back. We're now moving into week 3 of the data mining course. Um, we've done a little bit of data pre-processing. We've looked for possible errors in the data, outlier analysis. Um, we've done a little bit of analysis of the mutations, or in other words, the features. This week we're going to begin to think about a general data mining problem that we want to solve. And we'll focus on this general problem for the remainder of the course. This is the classification problem. If you have distinct groups of things, entities, in the case of our problem that we're working on this semester, you have distinct groups of patients, and the distinct groups are referred to as classes. Another way of describing this problem is each sample has a label associated with it, a category associated with it. In this case, cancer, non-cancer. In the case of, say, movies on Netflix or Amazon Prime, IMDb, the label could be something like a category. It's a crime drama, it's a thriller, it's a comedy, etc. So the classification problem is where you get a new sample that's not yet been labeled, not yet classified, and you want to use your pre-existing knowledge about all of the samples and their categories and their features to try to categorize this new sample that you've just collected. So, say for movie classification, a new movie has just been released. What category do we want to put it in? Is it a romantic comedy? Is it a thriller? What kind of movie is it? Is it sci-fi? So based on features that are associated with the movie, say, for example, the actors, the director, we can make a guess as to which category of movie we would place this new movie into. In the case of disease diagnosis, we may perform a genetic mutation analysis for an individual who is suspected of having a certain kind of cancer. If we look at the mutational profile of that individual, can we diagnose whether that individual has this type of cancer that we suspect or does not have that kind of cancer? That's the classification problem. We'll begin to work on this a little bit this week. We'll begin to lay a foundation that we'll build on as the semester moves on. We'll be looking at ways to evaluate the mutations, or in other words, ways to evaluate the features for the effectiveness in terms of being useful for the classification problem. One term that we use to describe this is the discriminatory power of a particular feature or mutation. How well does that feature allow us to categorize or discriminate between the members of the different groups? Can I tell the difference between an individual in the cancer group versus an individual in the non-cancer group based on looking at a particular mutation? How powerful is that mutation? And we'll look at particular quantities that are useful for assessing how good a particular feature is for the classification problem. We'll look at true negatives. A particular feature, in other words, a particular mutation, in this case, will correctly classify non-cancer samples as non-cancer a certain percentage of the time. Each time that a mutation correctly classifies a non-cancerous sample as being non-cancerous, we refer to that as a true negative. A true positive is every time that we correctly classify a cancer sample as being a cancerous sample. That's a true positive. So a particular feature or mutation will be good if it has a high number of true positives and true negatives, meaning that it's correctly categorizing or classifying samples as being either cancerous or non-cancerous. So we'll look at true negatives, true positives, and we'll look at false negatives, which is when an individual has cancer, but the diagnostic test says they do not. That's a false negative. Even more alarming to an individual would be a false positive, where an individual does not have cancer, but the test says, oh yes, this individual has cancer. You don't want to get that kind of a test result. So we'll evaluate the mutations, or in other words, the features, with respect to their ability to give high numbers of true positives and true negatives and low numbers of false positives and false negatives. And we'll also employ a couple of visualizations that are useful. We'll look at the stacked bar chart, and we'll look at the donut chart, and you'll get to generate these charts and use them to assess the effectiveness of particular mutations for the classification task. Look forward to working with you this week. Please move forward with the activities outlined.